Before we get into the episode today, a quick disclaimer. What you'll hear today is a general discussion only. Every building project is unique, and the right placement of products such as vapor control layers depends on the specific design and climate conditions. Always seek professional advice before making decisions for your own project. I hope you enjoy the episode. Hello and welcome to the Building Psychology Potty, where we talk about better buildings to live and breathe in. My name is Jess Kismet and I am your host. Today joining me is James Pinyon from Kingspan. He is the guy you want to talk to when you've got questions about insulation, thermal performance and making buildings work better. As Kingspan's technical services manager, James spends his days deep in the world of high-performance building envelopes, helping designers and builders navigate all the tricky stuff like compliance, fire ratings, and how to actually hit those energy targets in the real world. Welcome, James.
Thanks, Jess. Thanks for having me on. Talking about what my favorite subject.
Insulation.
That was a joke.
All right,
by the way.
so let's as I do with all of my guests, give the listener a bit of a background and context as to who you are. Although I sort of covered it in the intro, but a bit of your history and how you got to where you are today in Kingspan.
Right. So I started my working life as a roofer. So I worked out on roofs, installing mainly on roof tiles. So I worked out as a roof tiler for 5 years, installing insulation and sarking underneath roof tiles, and then putting tile battens on, and then tiled roofs. So my working life started out on the tools as a roofer. So I sometimes think about when I drive into Golden Grove, I think I probably put tiles on that house. I spent years and years in Golden Grove and Windvale and all those surrounding areas, working on tiled roofs and new subdivisions. So my history is working with roofing as a tiled roofer, and then I sort of moved over to working on iron roofing as well. So when I was a roof tiler, it was residential roofing. There were some little commercial roofs, but it was mainly residential, pretty much 99% residential. And then when I moved over and started working with iron roofing, it was mainly industrial and commercial type roofing, like shopping centres, larger type industrial type sort of sheds. So more commercial types roofs. So because I've spent a lot of time working on roofs and putting insulation in roofs, what happened was I ended up having a work accident, needed to find another job. And when the job came up with Kingspan and insulation, it just seemed to be a pretty good fit for me. So we tend to sort of gravitate towards things we know a fair bit about. And I applied for the job and I got the job, and that was like 20 years ago. So it seems like a lifetime. It was a long time ago.
Yeah.
So that's how I ended up here, because, like I said, I knew a fair bit about insulation already because I've installed a lot of it.
And you did new roofs. Did you also do roof repairs at all, or any rectification
yes, all the time.
work?
Yes, yeah. There are a lot of where we did re-roofing for sure.
So maybe it's actually not one of my planned questions, but I want to ask you about this. What were the main problems that you would see for roof restorations? Like, obviously mold is one of my favorite things to talk about. So did you ever find moldy roof spaces, and why do you think that was happening?
Okay. So if we go, I've been with Kingspan now for 20 years. Now, mold wasn't really an issue back 20 years ago because there wasn't, insulation, if you keep in mind, insulation really only became a mandatory building material like in the late 1990s and early 2000s. So although I say I've installed a lot of insulation, a lot of roofs that I did re-roofing on weren't insulated. They might have had some sarking underneath it perhaps, but they weren't insulated. Now, if your roof isn't insulated, there's not much difference between the outside air temperature and the inside air temperature. So you don't really get a chance to hit that dew point because the roof stays at either a constant hot temperature or a constant cold temperature because there's no insulation within the roof. So because that dew point wasn't reached, we didn't really have a condensation issue.
Yeah,
It's
of
only
course.
now that we're insulating. So yeah, it's only really now that we're insulating buildings more and more that it's creating issues with warmer, moist air inside the building. Because remember, the warmer the air is, the more moisture it can carry. And as that
Hmm.
warm, moist air moves through a building cavity, whether it be a roof or a wall, and now even a floor, because we're insulating floors now. But as that warmer, moist air moves through a building cavity and hits a colder surface, and the air cools down so rapidly that that air can't carry that moisture, it condensates. So we're now having issues with condensation, whereas 20 years ago we didn't really have a condensation issue.
Right. So when you were doing roof repairs, it wasn't a thing.
Not condensation as such. I mean, there were things that sort of started to wear out. I mean, silicon, for
Yeah, like
example,
roof
has got
leaks.
a certain, yeah. So you had roof leaks. So you had
Mm.
silicon, for example, had it's only got a certain amount of lifespan. Silicon, I was repairing. So if I was doing a roof replacement or roof repair, the main causes of them was because they might have had short sheets, for example. So where you got
Yeah.
short sheets and they're joining each other, it would be where they're lapped is where you might get corrosion because
Yeah.
you might get a little bit of moisture in between the two sheets where they're overlapped and joined, and that might start to rust out.
Yeah.
So if I was doing a roof repair, for example, 20 years ago, that roof might have been put down, 40 or 60 years ago. Those roofs didn't have.
Yes. 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 So the work now, obviously you're not running around on rooftops anymore, but
Mm.
do you see commonly in your day-to-day work these sorts of condensation and mold issues?
We do, and I know there are a lot of condensation issues I mean, the majority of projects I'm working on now are new projects, so if I'm talking to a designer or an architect, they're generally working on a new project and we're talking to them about the best way to insulate their roof, and depending on what their use of the building is.
Yeah.
Um, so, but yeah, there's definitely a high risk of condensation forming now because we're insulating so much more now. So,
Hmm.
so um, I don't think I'm really working on too many. I mean, there are some retrofits to a lot of buildings, which
Yeah.
which come up from time to time, where someone might have an existing building, they're doing an upgrade to the building, or they're putting an extension on the building, and you might come across, older types of the building that have some condensation issues.
Yeah.
But
Yep. Okay.
yeah, the majority of stuff I'm doing now is with new buildings.
New construction. Yep.
Yeah.
Okay. So, you've been around Kingspan for 20 years, and before that you were doing roofing. And so you've probably seen a lot of changes in that time. What have been the biggest changes in insulation? Or what have been the changes in insulation practices that you've seen?
Probably the introduction of higher thermal performance requirements. I mean,
Mm.
back when I started with insulation, if we talk about residential, for example, there's a couple of different factors here. You got residential, then you're commercial. But if we talk about
Mm.
residential, we were looking to achieve a 4-star as a residential when I first started. In 2006 when I was started, when I was 2004, sorry, when I had started, we were on like a 4-star energy rating. Whereas you could achieve that reasonably easily with an R3 bat on top of the ceiling and an R2 insulation in the wall cavity. Whereas now we've gone through the whole process. I mean, there's been a lot of introductions in that time, but the biggest change I've seen within the insulation industry is the requirements are getting more stringent and harder to achieve.
Yep. And how has the industry responded from your perspective?
It has responded pretty well. There's if you take some of the new insulation requirements out now. I mean, now we've moved into 7-star.
Hmm.
There's some builders out there, or there's some contractors out there who have never had to put insulation in certain areas where they do now. Now, probably the major one that sticks out when I think about it is if you look at the person, because we're now supplying insulation particularly up in the cold climate zones, like climate zone 6, up in the Adelaide Hills or the Barossa Valley type sort of area or Fleurieu Peninsula, those type sort of colder climate zones, climate zone 6, a lot of the residential buildings down there, to achieve a 7-star, they might have to put insulation underneath their slab on ground. Now, to put insulation underneath slab on ground or even slab edge insulation, now the contractors that would put that in would be the steel fixers who do the reinforcement rods for your concrete foundations or your Rio. Now those guys have never had to put insulation in before. So
That's an interesting challenge.
This is only something. Yeah. So this is something that's only come out over the last, typically 18 months to 2 years, where we're about to start insulating underneath concrete slabs. So going out and meeting with a bunch of guys on site and saying this house, to achieve the star rating, needs to have insulation underneath it, and the guys that are carrying around heavy Rio bars and being able to, once it's excavated, drop them on the floor, put them in place, wire them all together, and then now, before they do that, they're having to put insulation on top of the pads, on top of the Forticon. And they need to be reasonably careful with it because, insulation, is
it
really
breaks.
quite soft. There's nothing really structural to it.
Yeah.
So,
I actually heard a story the other day of, a waffle pod, a packet of waffle pods had been opened on a windy day. And they blew all over the road.
Went everywhere.
Yeah, because they're light.
Everywhere.
Yeah.
Yes, and if it's windy, the wind will pick them up and take them, and if they get smashed against stovey poles or cars or whatever else, they'll just break up. And the cleanup shoes, I've actually seen a couple of pictures where this subdivision was littered with what looked like snow, but it was actually waffle pods. And I just thought it would take a team of 5 guys, like literally 2 days, to walk around and pick that up.
Pull that up.
Like it was literally everywhere, probably over a good like, a couple of hectares site. It was a big subdivision.
Oh, wow.
Littered with it. And I was,
anyway, that's a big issue.
Anyway, I'm glad I had nothing to do with it.
But I digress. So you're talking about the steel fixers, and they're having to install insulation, and this is a challenge for them. It's new.
Yeah. So how the industry has responded, I mean, you do get a little bit of resistance, because it's something that they haven't had to do before. It is going to slow them down in them fixing their steel. So it does slow them down. It's something extra that they now have to do. So
do they price
a little
for
bit
it?
of resistance.
Do they know ahead of time that they have to do this, and do they price for it, or does it become a variation and a delay and that kind of thing?
I'm sure they probably would, but how they manage their variations and their costings, I'm not privy to. So I'm not sure about that, but I guess it's just something that they've never really had to install insulation before. So, like you said, you can get a little bit of resistance, but once you talk to them and you tell them how it is, they understand, well, that's just part of the job now. The job, that the world is changing, and they just go ahead and do it. But it's like anything. Whenever you got to try something new, you're always going to expect to get a little bit of, why are we doing this? And does it really matter? Does it make a difference? You're going to get a little bit of those sort of questions. But once you're sort of getting the flow of installing it, it just becomes part and parcel of the
normal,
job.
the new normal.
Yeah, exactly. The new normal. Good way to put it. Yeah.
It's time for a quick sponsor shout out. Today's episode of the Building Sciology Potty is proudly brought to you by our amazing sponsors, Enduro Builders and Climasure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages.
South Australia's first 10-star home was built in Woodford, and I understand Kingspan was the supplier of insulation for that project. Can you tell us a bit about that?
Yeah. So, I mean, that was a pretty exciting project. I mean, when you go back where the normal was I think we were on a 6-star home back then, that was a requirement. So remember, 6-star is the minimum requirements. SUHO, or Sustainability House, which, as you know, they are energy rating company, environmental sustainability consulting company. They designed that building and wanted to prove that you can build a 10-star home. So we were asked, so for them to be able to achieve 10 stars, they needed to, in some areas, use a continuous insulation and pretty much will beef up the insulation values for their house. So we supplied insulation that went on the outside of some of their reverse brick veneer buildings. So they had thermal mass on the inside of that house on some walls. And we provided insulation that went on the inside of some of their wall frames in other locations. So all we really did was provide the insulation, but it was sustainability house that did the design and the build and managed the whole process. But it was good to be able to say that our insulation helped them to be able to achieve a 10-star rating. So that was a pretty exciting project. And back at the time, we used the house to run a couple of meetings and building designers type sort of meetings. So it was a good chance to be able to show the house off and say that we played a part in insulating it.
Yeah, that was a really sort of innovative project at the time and remaining. It's still an innovative project now. So you said that you used continuous external insulation. This is not a common practice. So what product did you supply for that?
The product that was used back then was our Kingspan Cooltherm K12. So pretty much it's a rigid insulation board. It has foil on both sides. It was used on the outside of the frame. Then over the top of that, there was a batten. So almost like a drainage channel or a batten. Then they had exterior cladding fixed to that batten. And in some of the walls, they also used our PermaShield, our air cell PermaShield as well as a vapor control layer.
On the inside?
On the inside. Well, on the outside of they used the rigid board on the outside of some of the studs, and they also on different walls, and on other walls they used it on the inside, and on some of the other walls because obviously there's different sides to the house, different orientations, and on some of the other walls they used our PermaShield, our air cell PermaShield insulation, as a vapor control layer. Yeah.
Yep. And you mentioned reverse brick veneer. So, I mean, this is not really to do with Kingspan, but just for the listener, reverse brick veneer is when you put the bricks on the inside of the stud frame instead of the outside of the stud frame. And James, you mentioned thermal mass. So brick is a thermal mass product. It absorbs heat and releases heat slowly. So that was a really important strategy for the 10-star house in getting it to achieve that 10 stars, is moving the bricks on the inside where it can actually contribute heat to the habitable space.
Absolutely. So it's a great way to build.
It actually is. And the hardest part about doing reverse brick veneer is finding the brickies to actually lay the bricks back to front. So they've got to do it on the opposite side of so it messes with their brains a little bit to actually get them to turn around and do it from the other side.
Do it on the inside.
Yeah, but it's a very effective, extremely effective strategy in increasing your NatHERS star rating. So let's move on to thermal bridging. So, I recommend Kingspan boards sometimes for externally insulating steel. So in fact, I was on site only 2 days ago talking to a builder who had some steel beams and steel columns, and I just said he didn't have much space. He didn't have much space on the outside of his building, but he did have enough. And the K boards are quite dense, and so they give a high R value for a smaller thickness. So I recommended that he use one of the K boards for insulating his steel. So is that something that you do, like when you are talking about thermal bridging to builders and trades? Is that what that product is used for? Sometimes
a lot of the times it is, and we did use our Kingspan K12 on the outside of frames quite extensively. Things have changed a little bit now since the introduction of 2022, NCC 2022 and 7-star. As you'll be aware, NCC 2022 now talks about on the outside of your primary insulation layer, you really need to have a vapor control layer. That's either going to be like a class 3 or a class 4 If you
Yeah.
put our
Vapor
cake,
permeable.
a vapor permeable barrier, I
Yeah.
should say. You put that on the outside, you're kind of going to negate that vapor permeability from it now. So we really are sort of suggesting to people now to put it on the inside of their frame. I mean, you still can put it on the outside of your frame, and we've actually had a few woofy analysis carried out with our rigid board on the outside of a steel frame.
Mm-hmm.
And, and it has showed that we haven't had a risk of condensation. Well, there's always a risk of condensation forming, but we have showed that the dew point hasn't been reached.
Mm-hmm.
But to play it safe now, to do that, you would need to get a performance solution, and getting a performance solution carried out for a residential home, is going to be just an extra consultant within the mix, which you probably don't want to do. What we are suggesting to people to do now is, maybe if they do need to use a rigid insulation board, put it on the inside of the frame. So that way you have your plasterboard, rigid insulation board, then you would have your frame, your stud frame, vapor control, and inside that stud frame you'd have your R2 or your R2 bats. Then you'd have your vapor control permeable barrier, and then whatever exterior cladding you use, whether it be brick veneer or you use some type of other exterior cladding. But yeah, really now we're sort of really leaning towards people using our rigid insulation board on the inside of the building.
That's interesting. So when I was talking about externally insulating steel, I was referring to only the steel itself. So I wasn't suggesting that we put that across a whole building. I was talking about
just like with strips.
Yeah. Just the column or just the beam.
Yep.
Just to keep that steel warm, because keeping that steel warm is really important.
Yes.
But it's interesting because what you're actually saying, James, about external insulation, the reason that condensation forms is because it hits a cold surface. So if you end up, although the K-boards are not vapor permeable, they are keeping the. So I don't know if you've heard of Joe Seabrick. Have you heard of Joe Seabrick? Talk about him a lot on this podcast. He's
yes.
So good. So he's the guy, the building science genius over in the US. And he talks about the perfect wall. And the perfect wall has got all of the insulation on the outside of the structure, on the outside of the frame. And he's got his vapor control layers and his air control layers and all of that outside of the frame. So actually putting external insulation, and this is not technical advice for the listener, you must always get advice on your own individual projects. However, the building science is that if you keep your structure warm and you keep the vapor from getting into the wall system, then you're not going to have a problem inside the wall. So although the Kingspan boards are they're not vapor permeable, the performance solution, you said that you've had some hydrothermal analysis done and it hasn't thrown a problem. If you have external insulation, that is working towards the ideal wall structure.
Yes. Yeah, and I agree with you, but the NCC 2022 clearly states that if you're using a vapor permeable, so if you're using a membrane on the outside of your wall and then on the outside of your primary insulation layer, it needs to be vapor your wall needs to be vapor permeable. So so we if we go ahead and say, look, I believe, and the building science shows insulating on the outside of the wall is a better way to do it. Unfortunately, it flies in the face of NCC 2022 and those.
Yeah, it's riddled with risk.
Yeah. Yes.
Yeah, and application of those products is important. So you're suggesting that the insulation go on the inside instead. Are those boards taped?
We would recommend taping. Yes.
Yeah.
We would recommend taping, but putting the boards on the inside of the wall. What that's going to do is it's going to keep the internal side. It's going to stop the warm, moist air. When I say warm, moist air, the air from inside the building. Hopefully the room temperature inside. We're talking about residential now. Inside the building is a comfortable 22 or 23 degrees. Like I said, there's a certain amount of moisture that is always going to be in warmer air, and as that warm air gets onto the plasterboard. The idea of having insulation there is it's going to keep that plasterboard warmer because the insulation is behind it and it's not going to be getting so cold in the fact that if it is attached directly to a steel frame. You know, I've seen projects where there's been, and I'm not discounting steel framing because I know it plays a big part in the residential landscape out there, but I've seen where what they call ghosting, whereas you've got a steel frame structure, you've got plasterboard, and in those cold winter months, you know, June, July, and August, for example, it might be 23 degrees inside, or hopefully it's 23 degrees inside, nice and comfortable, but it could be 5 or 6 degrees on the outside, and that steel frame has become quite cold. And where those studs are, you can see a little bit of condensation forming on where those studs are because it's quite colder on those areas. They call that ghosting. So I've seen that before. So the idea of having insulation on the inside is to stop that warm air touching those cold.
And do you recommend that because I imagine you do site visits and things like that with the projects that you're providing insulation to, do you ever talk about taping up your penetrations and things like that?
Yeah, absolutely. So penetrations, anywhere where warmer air can escape, I mean, it does get pretty difficult. And this is why it's important to have that vapor permeable membrane on the outside because I mean, even warmer air can come through things like light switches, for example, and power points.
Yeah.
So you're always going to get a certain amount of warm air going into what is effectively going to be a colder cavity and condensating. So if it does condensate, you need to be able to release that vapor to the outside of the building, and that's where your vapor permeable membrane comes into place.
Yeah, that's where it's absolutely crucial. And where those vented cavities are absolutely crucial, so you can get the air movement through the external side of the membrane to dry it all out.
Yep.
100%. All right. So, what about some of Kingspan's latest innovations? Have you had much innovation in products going on behind the scenes, or anything that's on the shelves at the moment?
Yeah, we have. I mean, there's a couple of innovations that we're doing as far as applications go. I mean, insulating underneath slabs on ground is quite innovative, and slab edge insulation. I mean, these are a couple of applications that are quite new to us. Even, I mean, you know, here in South Australia or here in Australia, we haven't had to insulate really underneath slab on ground, you know, until the last couple of years. So that's quite a new approach for us and the industry. Another application which is quite innovative is in the commercial world. We're talking to a lot of builders and plasterboard installers now, and instead of them inside of a concrete precast, where let's say you take like a homemaker centre. I mean, keeping in mind every building that's air conditioned needs to satisfy an energy requirement and have insulation if it's going to be air conditioned. So on the inside of let's say like a small homemaker centre or a large homemaker centre was built out of concrete precast, what the traditional way of insulating that building would be to basically build a metal stud frame on the inside of that concrete precast, put insulation in there, and then put plasterboard against that metal frame. What we've been doing over the last 12 to 18 months, which is pretty innovative, is putting our rigid K12 board straight up against the wall, so straight up against the concrete. And then once the entire wall has a continuous insulation going over the wall, and then with adhesive fixing plasterboard directly to our insulation. So you're basically eliminating the cost to buy the steel for a steel stud, and you're eliminating the cost to actually build the steel stud. So it's a quicker way to insulate and install it, and it's cheaper to install it. So that's quite innovative. Services can be chased out the back of the insulation, so you know, for electrical and water, but that's all details that we provide to the plasterboard installers as they're doing the job. Other innovations have been what we're introducing now into the industry is what we call warm roof. So there's quite a lot of concrete roofs on high-rise tops of buildings, or they don't have to be high-rise, but there's quite a lot of concrete roofs. The traditional way of insulating a concrete roof would be to put either insulation up underneath the concrete, like a typical soffit application, or even build a suspended ceiling and below the concrete and then insulate that.
Yes.
But the environmental sustainability consultants and the engineers are saying there's a lot of benefits in putting insulation on top of the concrete roof and then putting a membrane, so a membrane and a waterproof membrane over the top of that, and it can be trafficable. It can have pods on there for solar panels. So we're doing a little bit of that at the moment as well within Australia, and that's a pretty innovative way of insulating. So we're partnering up with waterproofing contractors who are carrying out the work, and just a really good way of insulating concrete roofs. So there's a couple of innovative.
That's awesome, and that's that external insulation piece again. You're keeping the structure warm. That is what you need to do for optimal energy efficiency and optimal condensation risk mitigation, and also waterproofing. Like if you are putting that waterproofing barrier on top of the insulation, then that's how you protect the insulation, but it's also taking care of waterproofing.
And it's also how you protect the concrete as well. I mean, concrete, as we've already talked about, has a lot of thermal mass. So on a day that's 25 degrees or 30 degrees, that roof can hold a lot of temperature, and it can get quite stable. But if you get a shower, if you get a rain shower, that roof can cool down by 10 to 15 degrees within a few minutes. That loss of heat exchange in such a rapid short time can also cause cracking as well. So being able to insulate above, and then if you've got your air conditioning, whether it be cooling or heating on the inside of the building, and that concrete structure above gets to a certain temperature, it's going to stay very stable, particularly when the insulation above is protecting it from the outside environment. So it's a good way to insulate.
Yeah, it is. That's great. That's really great to hear. How do your different products apply to different climate zones? Because you mostly work in South Australia and Northern Territory. Is that right?
Yes. So absolutely, I do. Yes.
Crosses a bunch of climate zones there.
It does. So for example, if we were in climate zone 1 or climate zone 2, so northern Australia, we would really where it's very hot, and where it's hot, say up in Northern Australia, and people inside the building have an aircon on, so they might have an aircon on that's cooling the building down to 22 or 23 degrees, but the outside of the building, because it's so hot, it's 35, 36, 37 degrees, and because the air is so humid up there, the vapor drive is different. The vapor drive is trying to get into the building. So what we want to do up there is trying to really insulate on the outside of the building and have good vapor barriers up there in Northern Territory. So the vapor barrier that we'd use on the outside of a wall frame would be our Insulbreak 70, for example. Whereas we wouldn't use our Insulbreak 70 on the wall down here, because on the walls down here where it's cold outside and we want it to be warmer inside, the vapor drive is on the inside trying to get out. So it's the opposite. So although we have only one set of products, we have a whole range of products, but we have some products that are vapor permeable, which we'd use in colder climate zones, and we have other products which are full vapor barriers, which we'd use in the warmer climate zones. So depending on the climate zones, I guess what would change would be the location of where you put your insulation. So it's really the location of where the insulation goes.
Which side of the wall?
On which side of the wall, the warm side or the colder side.
Yep. And as far as vapor permeability goes, what are Kingspan doing to address the vapor permeability of their external products?
We are about to release another material called Styco, which is a wood-grained fibre material, which again will be used in colder tops of the climate zone. So it is a rigid insulation board that will be able to provide a vapor permeance of class 3 and class 4, depending on which material that we use. So that's something that's going to be pretty exciting. That's going to take care of thermal bridging and vapor permeance, and it's going to give you a continuous insulation. So that's something that we're doing there.
Styco is a German company, isn't it?
Yeah, so you've heard of it then?
Yes, I know Styco. So did Kingspan buy Styco?
Yes. Yes.
Yes. Okay.
So
Interesting.
so Kings so with Kingspan, I mean, obviously we're in the business of energy efficiency and sustainability. So Kingspan is very good at identifying good materials and then acquiring those companies and bringing them under the fold of Kingspan. So yeah, so I'm looking forward to bringing that out because there's so many areas where that could be used. So many
Oh,
buildings and so
100%.
many areas.
Wood fiber, and they've got a lot of their product range is quite broad. Which products of theirs are
Yes.
you bringing in? All of
I
them,
can't.
or just a few?
Yeah, no. It won't be all of them. It'll be the most popular ones. But we're going to have a release. We're going to have a launch in a couple of months. So as soon as we have that
Yep.
launch, I'd be happy to jump on and give you
All
more
right.
information about it.
All
Yeah.
right. We might by the time this episode is released, it will be
We
a
might
couple
be
of
there.
months. So we might even
Okay.
we might even do like a bonus episode where we tack on some information about your launch.
Yeah. Okay. Sounds great.
Alrighty. Because these episodes are fortnightly, so we can put in a little bonus episode in that middle week and have a little chat about it. Okay, so I've got 2 more questions. Okay. What trends do you see shaping the future of insulation and sustainable building in Australia?
Well, definitely the actual clear trend is insulation requirements are getting higher and higher. So they're not going to wind back any. They're going to get higher and higher. If you look at insulation of glazing, for example, all windows now, are becoming almost like double glazed windows. So the majority of residential buildings are going to have double glazed windows, and that's good for the industry because double glazed windows are going to perform better thermally. But as they start to make these double glazed windows, the price of that's going to go down as well. So where I see the trend going is where building materials are starting to improve. There's innovations in building materials, and the insulation requirements are just getting higher and higher.
Mm-hmm. Yep, 100%.
That's where I see the trend going. The trend is going up. The trend is up.
Is it true that get a little bit political here for a minute about the American election, Donald Trump? I heard that he was eliminating their Energy Star system over there. So we have our Net Her Star ratings here in Australia. Have you heard this? Is that true?
I haven't heard it. It wouldn't surprise me. I haven't heard it, but it wouldn't surprise me. A lot of see, the way I see it, and I've had the same thing myself. Whereas I did an extension to a little shack that we have, and I insulated under the floor. Now my own dad was saying, "What are you insulating under the floor for? It's heat rises, doesn't go down." The older, and not to generalize on this, but a lot of the times the older generation that didn't really have insulation or have to put insulation in there are probably finding themselves at a point where they're saying, this is just adding extra cost to the building. Is that adding extra work to the contractors? Why do we need it? They've been used to living in cold buildings. They've been used to living in hot buildings. It's us that are sort of growing up and having to insulate and now know that insulation really works. It matters. And I believe that, and the reason why I'm still here after 20 years is I know that living in a building that is that you just can't keep warm in the winter, and living in a building that you just can't keep cool in the summer is really unhealthy for you. If you're getting a cold or the flu, 3 or 4 times a year because you just cannot keep the building warm, that is really unhealthy for you. So
yeah, it's unhealthy for everyone.
It's unhealthy for everyone. Yeah. So I just think that a lot of the older generation see insulation as just an extra cost and extra work. So I wouldn't be surprised if Donald Trump is doing that.
I'm going to have to research that and find out.
Yeah, research and let me know.
Yeah. Oh my goodness. Okay. Final question I ask everybody. Out of everything, all the experience you've got, everything you've learned through your career, what is the one thing you want the industry to know?
Probably
take your time.
Probably Probably insulation matters. Insulation really does matter. Like I just mentioned, living in a cold building throughout winter, in a building that you just cannot keep warm, is so unhealthy. Like I said, getting a cold 3 or 4 times a year is not good for you. I've lived in buildings. I've lived in houses where I can feel cold air rushing over my feet when I'm sitting on the lounge. Because the seals
Haven't we
between
all?
because the seals between the floor and the walls are not sealed up properly, or the seals under the doors are not sealed. But there's things we can do about that. Just things we need. One thing I can say is, if you've got a building that is letting cold air rush in throughout winter, you can, with the use of a lot of silicon tubes, you can actually cork them up, or no more gaps. You can cork them up. You can put seals underneath doors. You can, and there's a lot of things you can do for a relatively low cost that can make a difference. You don't have to go out and spend thousands of dollars on new insulation, pulling plasterboard off, re-insulating, recladding the outside. There's a lot of things you can do to make a building perform better in these colder months and these warmer months.
Right on. Thank you, James. Well, I think that's all the questions I had for you today. So thank you for taking the time out of your day to talk to me. I really appreciate it.
No worries at all. Okay, thanks for that. I'll look forward to hearing it come out.
Cool. And I will chase you up on your launch, and we'll do a bonus episode.
Okay,
Sounds
great. Good on you.
All right, thanks, James.
Okay, thanks, Jess. Talk to you soon. Okay, bye.
That is all for today. Thanks so much for tuning in. There'll be another episode in a fortnight, so if you would like to listen into the types of conversations that I have all the time, please subscribe on your chosen platform. Rate the show, leave a comment, whatever you like, share with your friends and family. I'd love for you to spread the word about the Building Sciology Potty. There's a link in the episode description where you can head to a landing page, and there are some show notes there with relevant links and a full transcript of the show as well, and also links to my socials. So if you're not already, I'd love for you to follow along there too, as I share lots of building science and building biology tips. There's also a contact page where you can send me an email or even a voice message. So if you've got questions or suggestions or guest ideas, I'd love to hear from you. I want to know what you want to know, so please get in touch with me. Thanks again. I'll be back in 2 weeks. So until then, happy healthy building.